Hello everyone. There is difference between thinking machines and machines who mimics to think. The current scenario is dominated by LLMs generated AI hype. It is a sophisticated mimic, a pattern matcher of unprecedented scale, but it lacks the genuine understanding, perception, and common sense that are the hallmarks of human intelligence. LLMs can identify and replicate complex patterns from its training data. It does not possess a genuine understanding of cause and effect. For instance, if you ask a LLM that, if I shout a block of cheese, would it get warmer? A human would immediately dismiss this based on an understanding of sound waves and heat transfer. LLM might search for patterns connecting shouting and temperature, and if none exist, it might provide a speculative or nonsensical answer. This lack of common sense and causal reasoning can lead to confidently incorrect or even dangerous suggestions, especially in high-stakes domains like medical advice or financial planning. Large language models can generate information that is plausible sounding but completely fabricated. This can happen for several reasons. The training data may contain conflicting information, the model may over-extrapolate from a pattern, or the user's prompt may be ambiguous. Essentially, when the model doesn't know an answer, its probabilistic nature might lead it to invent one that seems statistically likely. For instance, a lawyer once used a large language model to prepare a legal brief, only to discover that the model had cited several entirely fictional court cases. The case names, judges, and legal reasoning were all convincingly written but had no basis in reality. Similarly, a model might invent biographical details for a historical figure or provide a recipe with non-existent ingredients. This makes it unreliable as a sole source of factual information. All outputs, especially those involving data, facts, and citations, must be independently verified. The foundational world model of LLM is built during an intensive training process that is computationally expensive and time-consuming. While features like Google search integration can provide it with up-to-the-minute information on specific topics, its core understanding of the world is based on the data it was trained on, which has a cutoff date. If you ask about a major world event that happened yesterday, LLM can likely find information about it through search. However, if you ask a more nuanced question that requires integrating that new event into its broader understanding of geopolitics or economics, it may struggle to do so as deeply as a human expert who has been continuously learning and adapting their mental model. Just as it is difficult to update its core knowledge, it is also challenging to make a large language model forget specific information. Information is deeply encoded in the neural network's parameters. Removing a specific piece of information without affecting the model's overall performance is a complex technical challenge. If it is discovered that particular fact in its training data is incorrect or harmful, it's not a simple matter of deleting a file. The influence of that data point is distributed across the model's network. This has significant privacy and safety implications. If private or harmful information is inadvertently included in the training data, it can be very difficult to remove it completely. Moving further to reach the goal of building really thinking machines that augment human abilities, we need a framework incorporating human versatility must emerge from a thinking machine architecture in which each of several different reasoning mechanisms and representations can help overcome the deficiencies. My hypothesis is that such an architecture can help overcome this problem. It is based on evidence of many kinds from several disciplines and constraints on evolvability, implementability in neural mechanisms, and functionality. The three layers operate concurrently and do not form a simple dominance hierarchy. Arrows represent flow of information and control, and boundaries need not be sharp in all implementations. Different components, instead of forming parts of simple pipelines, can concurrently send information of various kinds to arbitrarily many other components, allowing a wide variety of feedback mechanisms and triggering mechanisms. Reflective processes add the ability to monitor, evaluate, and to some extent control processes occurring within the system in much the same way as the whole system observes and acts on the environment. Deliberative processes are those in which alternative possibilities for action can be considered, categorized, evaluated, and selected or rejected. More generally, a deliberative mechanism may be capable of counterfactual reasoning about the past and present and hypothetical reasoning about the future. The depth, precision, and validity of such reasoning can vary. Reactive processes are those in which internal or external states detected by sensors immediately trigger internal or external responses. I will further share the details of architecture and its underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.